So last night when I recorded lesson 9, there wasn't a sound. I'm sorry about that. They fixed my board, and I think I have sound now. So today I'm teaching about something called mean absolute deviation. You know each one of these words separately. Mean is the average. Absolute comes from absolute value, which is the distance a number is from zero. And the deviation is how far a number is from the mean. Okay, this is lesson 9 of module 6 of statistics, and it piggybacks off of lesson 8. In lesson 8, we found the range of the numbers to discuss variability, or how far the numbers vary. But in today's lesson, we are going to use mean absolute deviation to talk about the variability of data, okay? To start using the mean absolute deviation, otherwise known as the MAD, mean absolute deviation, you have to start by drawing these tables, okay? The first column is going to chart all the temperatures in the dot plot above. The second column is going to tell you how far these temperatures are away from the average, and the absolute deviation is going to tell you how far these numbers are away from zero, or the distance they are from zero. So the first thing you need to do after you've copied both the charts down is add up all of these numbers and find the average. 54 plus 54 plus 54 plus 58 plus 64 plus 64 plus 64 plus 64 plus 68 plus 72 plus 72 plus 72. That gives you a sum of 760. And I believe there's 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to divide 760 by 12, and it's going to be a mean of 63.33333. The mean temperature for city B is 63. I'm going to round it in order to make the rest of this lesson a little easier. So now you take each one of these temperatures and you find its deviation, which is the distance a number is from the mean. 54 minus 63 is down 9. 54 is down 9 from your mean. 58 minus 63 is going to be down 5 from your mean. 64 is going to be up 1. 68 up 5. And 72 is going to be up 9. So these are how far each one of these temperatures is from your mean temperature of 63. Now in this column, you are going to find the absolute value of the deviations, or how far they are from 0. Negative 9 is 9 away from 0. Negative 5 is 5 away from 0. 1 is 1 away from 0. 5 is 5 away. 9 is 9 away. Now you have a column for absolute deviations. Now to find the mean absolute deviation, you add all of these up and find the average again. Okay, you're going to get a sum of 68, and when I divide that by the 12 absolute deviations I added, you are going to have a mean absolute deviation for city B. I'm going to round to the nearest 10th. Okay, so it's going to be 5.7 for this city. Okay, so let's try the same thing with city G. Okay, remember, to find the deviations, the first thing you have to do is add all of these numbers and divide by 12 to find the mean. Okay, so when you add all those numbers, you should get 757. When you divide that by 12, ooh, we also have a mean temperature of 63. Okay, now I'm going to go find the deviations from all of these. Some of them might be the same from over here. 54 is down 9 from your mean. Okay, 57 is a new one. So 57 minus 63, we have a deviation of minus 6. 60 is down 3, or negative 3. 64 is up 1. 68 is up 5. And 70 is up 7. Now I'm going to find the absolute deviation, which means how far all of these numbers are from 0. Negative 9 is 9 away from 0. Negative 6 is 6 away from 0. Negative 3 is 3. 1, 1, 1, 1, 1, 5, 5, and 7. Beautiful. Now I'm going to add this column and find the mean, or the average of it. 9 plus 6 plus 3 plus 3. I have 1, 2, 3, 4, 5 ones, so I'm just going to add 5. Then 5, 10 plus 7 is 17. And altogether, this is 12 numbers that I added. So when I divide that by 12, I get a MAD of, if I round it to the nearest tenth, of 3.6. Now, you might be asking yourself, what does this mean? And that's a great question. This means that city G has less variability because its MAD is lower. Okay? City G's temperatures are on average 3.6 units or degrees away from its mean. So if your mean is at 63 and you're drawing your triangle here, okay, your temperatures have a deviation of plus 3.6 or minus 3.6 on average, okay? If you look at this side, the mean temperature is also 63, but now on average it could be plus 5.7 or minus 5.7 away, okay? Now let's see if you can do one on your own. If you need more time to copy this, please feel free to pause the video. Okay, I'm going to give you 2 sets of 5 numbers. Sorry, I'm doing this in my head, but hey, now you get to see how a math teacher does it, okay? That's 1, 2, 5, 6, and 6, okay? Now I'm going to give you a different 3, 4, 4, 5, and 3, okay? I'm actually going to switch this 3 and this 4 around to make my numbers order least to greatest. Thanks for your patience while I'm doing that. Okay? Now, we're going to find the MAD for each one of these to help us understand which set of numbers has more variability. You can pause the video after I make these tables and try it on your own. Numbers, deviations, absolute deviations, okay? Our numbers here are 1, 2, 5, 6, and 6. Okay, over here, I'm going to do the numbers, the deviations, and the absolute deviations. Okay, so I have 3, 3, 4, 4, and 5. Okay, the first thing you need to do is find the average. You can't find the deviations without the average. So let's write the mean up on top here. 1 plus 2 plus 5 plus 6 plus 6 is 20. And 20 divided by the 5 numbers you added gives us a mean of 4. Now, with your partner, okay, you can pause the video at this point. I want you to see if you can find all the deviations and the absolute deviations correctly, okay? And when you think you have it, you can play the video again. 1 is down 3 from your mean, 2 is down 2, 5 is down 1, 6 is up 2, and 6 is up 2. Now, when you go to make the absolute deviations, you're really finding how far these numbers are from 0 or their distance. You make all of them positive. 3, 4, 5, 6, 7, 8, 9, 10. And when you do 10 divided by the 5 numbers you added, okay, you have a MAD, or a mean absolute deviation, of 2. I want to teach you what this means. That means, on average, this set of numbers, each number on average is about 2 units away from the mean in either direction. So if you have your mean here, it's going to be plus 2, minus 2 on average. That's the MAD, okay? So now I'm going to come over and I'm going to do the next one, the second set of numbers. I'm going to first find the average. Ooh, Mrs. Kramer is going to change one, because that's not going to work out for you, okay? Let's try again. 3 plus 3 plus 4 plus 5 plus 5 is 20. When you do 20 divided by the 5 numbers, that gives you a mean of 4. Now pause the video. See if you can find the MAD on your own. See if you can do this whole process by yourself, okay? Find all the deviations, positive or negative, find their absolute deviations, add this column together, and divide by 5, okay? So, if I could get there. 3 is down 1 from your mean. 4 is your mean, so it's 0 away from it. 5 is up 1, 5 is up 1. Now I'm going to make these absolute by finding out how far the distance is from 0. Okay? When I add these all up, I get 4. And when I do 4 divided by 5 on my calculator, I get a MAD of 0.8. Okay? That means when you have your mean of 4, okay, on average, this set of numbers is 0.8 away in either direction from the mean, which means this set of numbers has way lower variability. Okay? Check with your classroom teacher now. I'm sure you're going to have a Google Classroom assignment on mean absolute deviation. Okay? Good luck.